Alright guys, I'm going to go over now a couple of rules called the sum and product of the roots. Now this is dealing with the sum and product of roots of a quadratic. Okay, you could, I'm sure, make similar rules for any other type of function, but we're going to do it here. Now I'll be straight up honest with you, I have no idea why we're even learning this. I've never used it. I can't really see any purpose for it at this point in time, other than the fact that IB can now give you more difficult questions that include more difficult problems, because now you have one more thing that you've learned. So sorry, that's the deal. You've got it. We're learning it. We'll be able to work with it. Okay, but let's kind of look at it. So what we're going to do is we're going to say, okay, given this quadratic formula, if it has real roots, and it really doesn't matter if it's real roots or imaginary, but if it has real roots, then one root will be alpha, the other will be beta. So these are the roots. Now it's possible that those are the same root, okay? That they have the same value. Sorry, not that the same root, but that they're the same solution, the same value. So what we're going to do is we're going to look at two situations. We're going to look at what do we get when we go alpha plus beta, and then we're going to look at the product. What do we get when we do alpha times beta? And you may say, but there's an infinite number of quadratics. How am I going to do all of those? Well, we're not going to do all of those. We're just going to say, all right, I know that for a quadratic, the solutions are x equals negative b plus or minus the square root of b squared minus 4ac, which is also the discriminant inside there, right, all over 2a. And so what I'm going to do is I'm going to say, okay, well, that means that alpha is going to be negative b plus the square root of the discriminant over 2a, and beta is negative b minus the square root of the discriminant over 2a. All right, so let's see what happens when we do alpha plus beta. Well, we're going to add those two together, so we'll go negative b plus the square root of the discriminant over 2a, and then I'm going to add negative b minus square root of the discriminant over 2a. Now you'll notice they already have a common denominator, so I can just add the denominators together. I've got a negative b and a negative b, which will give me negative 2b, and then I've got a positive square root of discriminant and negative square root of discriminant, which are going to cancel out, leaving me with negative 2b over 2a. The 2's cancel out, which means that alpha plus beta is equal to simply negative b over a. Now, the use of that I'm not sure, but other than for just the pure love of mathematics, that sounds like something you'd say when you're really angry. For the love of mathematics, why? You know, anyway, but yeah, so we've got alpha plus beta. Let's see then what happens when we take alpha times beta. Okay, so this time we're going to take the negative b plus the square root of the discriminant over 2a, and we're going to multiply it times negative b minus square root of the discriminant over 2a. All right, now notice that the number in front is the same and the number in back is the same, but the sign is different. This looks a lot like a plus b, a minus b. They're on the top of my fractions, right? The bottoms I'll just multiply straight across, and we know that a plus b times a minus b is a squared minus b squared. So that's exactly what we're going to do here. We're going to simplify. We're going to say alpha beta equals b squared, because negative b times negative b is b squared. It'll always be positive. And then I've got minus square root of the discriminant squared, which is just the discriminant, all over, and 2a times 2a is 4a squared. All right, so now I'm going to go ahead and put the discriminant in, because I know the discriminant is b squared minus 4ac. And we'll notice that when I do that, I'm going to distribute this minus to both of those, which means I'm going to have a b squared and a minus b squared. Those are going to cancel out. And then I'm going to have a negative times that, which will leave me with a positive 4ac on top and a 4a squared on the bottom. The 4's cancel out. One of the a's cancels out, leaving me with c over a. So conveniently, I now have that alpha plus beta is negative b over a, and alpha times beta is just c over a. And so you can get the sum and product of any roots just by plugging in b and a. This was for the general form. This works in any situation. All right, now what I would like to do is show you another way to go about this. Okay, and so what we're going to do is we're just going to say, all right, let's take ax squared plus bx plus c, okay, equals 0. We're going to start by just factoring out the a, so that will leave us with x squared plus, sorry, no, we don't want to do that. What we're going to do is we're going to say, okay, well, we could take out the a, and then we're going to put our roots. Now, if those are really roots, then x minus alpha and x minus beta should work out there, right? If those are the roots, then x minus alpha, x minus beta should be factors of that function, right? With whatever a that is out front. It doesn't matter what that number is, because I'm going to go x minus alpha equals 0, and I'll solve for that. So I'll add alpha both sides, so x can be alpha, and same thing here. So this is a little bit, you have to think about this one, but that should make sense, that this should eventually be able to be factored in that form. That doesn't mean that alpha and beta are nice numbers. They could be decimals, they could be irrationals, they could be whatever you want them to be, but you could technically factor it out in such a way that if you FOILed and multiplied this all out, that it would give you that, as long as alpha and beta are actually the roots. Okay, now from this point, if I go ahead and multiply those things out, so I'll leave the a in front, and so I'll go x times x is x squared. I've got minus alpha x, and then minus beta x, and then plus alpha beta equals 0. Okay, and now I notice that both of these have an x, so I'm going to rewrite that. X squared minus x times alpha plus beta plus alpha beta equals 0. Okay, and now from here, if I then say, well, this should have been equivalent to that up there. So I'm going to say ax squared plus bx plus c equals a times x squared minus, I'm going to rearrange this, I'm just going to put the alpha plus beta in the front, x plus alpha beta. Alright, now I'm going to get rid of the a by dividing everything by a, absolutely everything. So that will get rid of the a over here. On this side I'm also dividing by a, which will leave me with x squared plus b over ax plus c over a equals x squared minus alpha plus beta x plus alpha beta. And please note, my friends, that we've got right here alpha plus beta and b over a. Note that it's a minus. That's why alpha plus beta is negative b over a. And yes, my friends, right here I got alpha beta, which is c over a. So again, we get exactly the same thing. So take note of that. We'll look through some problems and questions associated with that in class, and hopefully we'll be able to get in some good IB questions with that. All right, see you in class.